Stress in Malay is actually tekanan lah, ataupun stress lah, alright. So stress, we learn the normal stress and shear stress for today lecture, alright. So today objective, you will need to understand the concept of normal and shear stress, right? And analyze the design of members subjected on axial load or shear load, right? So this part 1, so I have divided into 3 parts. So this is part 1. So part 1 we learn regarding the normal and shear stress, right? So average normal stress. So normal stress, what is normal stress? That is intensity of force acting normal or perpendicular to area. All right. Let's say we have a bar like this. All right, we have bar. Okay, we have bar, and we have force this way. Let's say P. All right, we have P here. All right. So P is a normal load, right? Normal force. All right. What is normal stress? It basically P over A. So which A? Alright. A yang mana? So A yang inilah, A yang perpendicular kepada to the P. So this A. Alright. This A. Oh, okay. This area. Right. This one. P over A. So we have P is internal resultant normal force. A is the area at the section. And sigma is average. This is not shear. This is normal. Alright. Normal stress at the section. Alright. So that's the things. The normal stress. So okay. So example, we have the bar has a constant width of 35. Before that I go to units. What is the units? Units is basically force is Newton and A is meter square, or this is Pascal. Alright, Pascal. Alright, or if for the simplification, if the solution, if the question gives you in mm unit, okay, we also can write as a Newton over mm squared. This is equivalent to mega Pascal, right? You can prove it by yourself, right? But this is the simplification or the trick, because if it gives you, let's say 20 mm, you need to convert to meter. Is very challenging, right? You have 0.02 meter, right? And you want to times 0.02 meter, right? So this is challenging in your calculation. So simplification, you can use directly mm, but your unit later on is megapascal, right? You can prove it because m squared is equal to 0.0001 mm is equals to 0.001 meter. Alright. So square is become 0.0 or 1 to the power of 10 minus power 6. So this is megapascal. So let's say the bar has constant width of 35 mm and thickness of 10 mm. Right? Determine the maximum average normal stress in the bar when it is subjected to the loading shown. Right? So we have several bar here. Right? We have bar AB, we have bar BC, we have bar CD. All right. All these have a similar width and thickness. All right. Width and thickness. That means they have the cross section. This one is 35 and this one is 10. All right. So the area is 35 times 10. All right. 350 mm square. Right, that's the area for this bar. Okay. Only that bar AB, bar BC, and bar CD, they have different force. All right. You have 12 kilonewton here. You have 22. You have 4. You have 4. 9. You have 9. All right. Overall, this one is should be in equilibrium. If not, the solution is the question is wrong. Right. Let's say you have 12 to the left. All right. Check for equilibrium. Check for equilibrium. All right. Summation of fx is 0. So you have minus 12. You have minus 9 plus 4 plus 4 plus 22. All right. You should get is equals to 0. Right. So you have minus 12 minus 9 plus 4 plus 4 plus 22. So this one is 0. So it's okay. It's equilibrium. All right. So next you need to check. You need to identify what is the internal force for each bar. All right. So find force for each bar. Right. Find the force for each bar. Right. Let's say for bar AB. Right. So we have like this. We have 12 kilonewton, and then this bar. Right. This is A, and this is B. Right. 9 and 9. For bar AB, you need to cut bar AB. Right. You need to cut here. You cut here. Cut. Right. Bila kita potong, when we cut, it left with 12 kilonewton, and you cut this one. Right. So you need to identify the internal force. So the internal force is basically how much internal force. This is P. So in order it's in equilibrium, so P have to 12 kilonewton. Right. So this one should be in equilibrium. So P should have same with 12 kilonewton. Right. So sigma AB. Okay, we call it stress for bar AB is equals to P over A, alright, which is 12 kilonewton or 12,000 newton, right, over A. A is we already calculated before, mm square. So this one is, so 12 divided by 350, 34.3. So 34.3 mega Pascal. Right. So that is for bar AB. Right. 34.3 megapascal. Alright. Wait. Okay. So next we go to bar BC. Alright, bar BC. You need to find the internal force of bar BC. Alright. So bar BC is this one. This one is bar BC. Alright. So we cut bar BC. We cut here. We cut bar BC. Right. We cut bar BC. And we redraw the free body diagram for bar BC. We have A, 12 kilonewton. We have B, which is 9, and this is cut region. Alright, this cut region. Alright, this one is here. Alright, so you need to find the internal force for bar BC. So find the P here. Alright, P. The P should be equilibrium. Alright, so the P is 12 plus 9 plus 9, which is 9, 9, 18, 30 kilonewton. Alright, P is 30 kilonewton. Right, so you calculate sigma BC is equals to P over A, which is 30 kilonewton 350 millimeter squared. Right, so it's become 33 over 350, 85.7 megapascal. Right, okay. The cut region, before I proceed, this is option 1. Right, if you want to take the other half, let's say I cut this one, right, I cut this one, but I want to take this portion, right, I want to take this portion, let's say, so I draw again. Okay, bar BC also. I just want to show you. This was bar BC number 2. Alright. Let's say I cut the other half. Alright. So we have here is 22 kilonewton. Right. And we have here C, which is 4, and then this is cut region. Right. The area of the cut. This is so what is the internal force of P? Right? What is the internal force of P? P is basically 4 plus 4 plus 22. Right? You should get the same answer, which is 30 kilonewton. Right? So the direction, if C is in this way and C also in this way, 22 in this right direction, so P must be in left direction. So this one is become equilibrium. Right? Right. So same procedure, sigma C is equals to 30 times 3 over 350 to get 85.7 megapascal. So the answer is same with this one, right? No matter how you take the portion, either you take the left side or you take the right side, you should get the same answer. All right. Basically, we take the side which less force, like this one, bar AB. We take the left side. We have 12. If we take this side, also can, but this is so many force. You can do that also. Okay, but it's so many force lah, right, to avoid careless, right? So bar BC we have 87.8, 85.7 megapascal. So we left with one more, bar CD, right? So bar CD, alright. So bar CD in CD direction, right? So you can cut in here, right? Cut in here. So you left with 22 kilonewton and the cut region here. So this one is, how much is P? Right, so P is 22 lah, right? So it should be equilibrium. So P is 22 kilonewton, right? So sigma BC, sigma CD is P over A, which is 22 kilonewton or 22 over 3. (22 10^3) Newton over 350. So you get the answer 22 E3 over 350, 62.86 megapascal. So remember, megapascal is basically 10 to the power 6 Pascal. Alright. Right. So the question is asking for the maximum average normal stress. So the maximum is the answer is sigma. The answer is sigma BC lah. This one is maximum. Right. This one is 34. Sigma BC is 87. Sigma CD is 62. So the maximum average stress is 85.7 megapascal. Alright. Boleh faham Alright. Ada soalan tak? Before we proceed. Any question?
No, thank you, Doctor.
Alright. If no question, let's look at example number 2. Alright. So example number 2, we have 80 kilogram lamp and 2 rods AB and BC. If AB has a diameter of 10 millimeter and BC has a diameter of 8 millimeter, determine the average normal stress in each rod. Right? So this is a cable. So cable basically they have round shape of diameter. Right? So for AB they have like this. Diameter is 10 mm. Alright. For BC they have 8 mm. Alright. For cable, right? Cable you have round shape of cross section. Alright. So the force is this way, force in this way. So the area is perpendicular to the cross section. So you should measure the area for the cross section of the cable. Alright. So determine the average normal stress in each rod. So they need you to find normal stress for cable AB and normal stress for cable BC. Alright. So basically this one is P over A. So or which is force AB over area of AB. Alright. This one also same. Force BC over area of BC. Right. So area of AB is basically pi for the round shape, pi r squared, or pi 10 squared. Alright. So this one is shift pi times 10 squared. So 314 mm squared. 314 mm squared. Alright. Can you imagine if you use the units in meter? Alright. If you use unit in meter, you left with 0.01 squared. Okay, shift pi times 0.01 squared. Okay, you have 3.1 times 10 to the power of minus 4 m squared. So better you use this.
Sorry, Doctor. The radius is 10 or 5 because the diameter of 10 millimeter. The formula is
Yes,
5.
doctor.
Okay,
Five.
siapa tu? Thank you for remind me. Yeah, it's 5. Right? It is 5. Thank you for reminding me. This one is 5. Alright. So this one is 0.001 1, 2, 3. 1, 2. Okay. So the answer for A is the answer for area is pi r squared. Pi times 5 squared. So 78.5. 7. So 78.5 mm squared, or shift pi times 0.05 squared. 7.85. 7.85 times to the power of minus 5. Alright, so better you use these units. It's less headache for you to use your calculator. But remember, so Newton over mm squared is mega Pascal. Alright. So area AB is pi r squared. So area BC is pi r squared as well. But area for BC lah. Pi for squared is equals to 52.3. 50.3 mm squared. Alright. So now we have the area. We need to find force AB and force BC. So to find force AB and force BC, use your knowledge in statics or in chapter, I think chapter 3 or chapter 4. Alright. Use your knowledge in chapter 4 to find force in AB and BC. Alright. So you draw the free body diagram, right? So you have this FBC, and you have FBA, and the weight is, I think, 80 kilogram. Alright. So the angle is here, right? 435, and this one is 60. Right. So like you do in chapter 4, all right, so summation of fx is 0. So f minus fba. So these things you should expert, right, by now. cos 60 degree and plus FBC times 4/5 is equals to 0, right? And summation of Fy is equals to 0. We have FBA sine 60 degree plus FBC 3/5 minus 80 times 9.81 in Newton is equals to 0. Alright, use your calculator to solve this simultaneous equation. Right, so you have minus cos 60 and then 4/5, 0, sine 60, 3/5 and 80 times 9.81. So you have FBA is equals to 632.38 Newton and FBC is 395.24 Newton, right? Okay, so now find the sigma BA. This symbol is sigma, alright? Sigma BA, which is stress, normal stress. So FBA over area of BA, which is 632.38, right? Divided by, this one is Newton, divided by area of BA. Area of BA is 78.5 millimeter square. So you should get your answer 632.38 divided by 78.5. 8 megapascal, right? 8 megapascal. Okay. And then for sigma BC, same things, FBC over area BC. So this one is 395.24, right? This one, okay, divided by area BC. So area BC is 50.3 millimeter squared. So this one is Newton, right? 395.24, 52.3. So 7.86 megapascal, right? So this is your answer, right? For sigma BA and sigma BC, right? Okay. Any question so far? Easy, right? Okay. If no question, we go into more complicated questions. All right. So let's say we have a member AC. They have the vertical force of 3 kilonewton. Determine the position of X. Determine the position of X of this force so that the average compressive stress at the small support C is equal to the average tensile stress in tie rod AB. The rod has a cross-sectional area of 400 and contact area C is 650 millimeter square, right? So why they said compressive and tensile? So when we put a load here, alright, put a load here, so rod AB basically akan meregang lah, right? It will be in tensile. So they just state that tensile, and C will be compressed. So they said that this is compressed, right? So find distance x where the normal stress AB same with normal stress at C, right? Equal, right? This one is equal, right? So find x when sigma AB is equals to sigma at C, alright? Or F AB over area AB equals to force at C is equals to area at C. Alright, so this is idea how to solve this problem. Right, find the value of x equation. Right. So how to do this? We need to draw FBD first for this one. Right. Draw FBD to find what is the force here. Right. So if I draw the FBD, okay. So we have like this, and we have force AB this way. Only one force. Okay, and force B is force C. Alright, and here. Alright. Why don't you draw like this? Boleh tak? Dia macam ni. F A B X F A B Y F C X F C Y. Yang ni pun betul. This is also correct. But it will make you susah lah, very hard to solve this one because this one is two force member, right? So they have force B, force A, so two force member. Remember, two force member only have one force. The direction is in the line of action. So you left is only FAB. This one also two force member, alright? So you only have one force. So no need to put two force like this. Although this is spin, but this is two force member, you know the direction of two force member is only one direction to the line of action, alright? So let's say you have this one, right? A and B. Two force member is only act in this one, FAB and FAB, alright? Force at 2 points, right? Okay. So that is your FBD. So find the value of x. Alright, find the value of x when the sigma is equals. So we have 3 kilonewton and the direction is x. Right? And we have Fc. Alright. So you left with summation of Fy 0 and the summation of Fx 0 and moment at any location. Let's say moment at A is 0. Alright. So this one is no use because you have no x direction. You only have Fc in y direction, 3 also in y direction, FB also y direction. So you use only these two equations, right? So Fy is 0, so you have FAB minus 3 kilonewton, right? Plus Fc is equals to 0, right? And then for moment about A, you have minus 3 kilonewton times x, and then this is clockwise, negative, and then plus FC times the distance. Distance here is 200 mm. Alright, so 200 mm. Positive because it's clockwise, it's counterclockwise. So you have this one is also 0. So this is question number 1, question number 2. Alright. 1, 2, 3. See? Okay, you have 3 equation. You have 3 unknown. You have FC, you have FAB, and you have X. You have 3 unknowns, but you only have 2 equation. So you need 1 more equation. Right? So 1 more equation is come from this equation. Right? From this equation. So this is equation number. This is equation number 3. Right? So FAB over area AB equals to FC over area C. Alright? Or you can say like this lah, FAB over area AB. Area AB. Area AB. Area AB is pi r squared, which is pi. Radius for AB is, oh, it is given, right? The cross-sectional of root is 400 and contact area at C is 650. Alright, so you can use directly lah. No need this one, right? So FAB over area AB is 400 meter square is equals to FC over 650 millimeter square. So this is question number 3 lah, right? So you have 3 equation, 3 unknowns, FC, FAB, and S. Okay, so you can solve this 3 equation. You can use your calculator, right? So you can get your answer lah. I did not show here, but you can directly find your answer. Alright, and S is, I think this slide have the answer. Oh yeah, they have the answer. When you use F, this equation number 1, equation number 2, and this is equation number 3. Right? So you solve this 3 equation, you should get the answer lah. FAB this much, FC this much, and X is 124 mm. So this one is 124 mm. Alright. Okay, so the basic idea, you need to strong knowledge in static lah in your chapter 4. If not, the solution is wrong lah, because in this chapter, in this topic, the formula is only sigma is P over A. Okay, that's it. This is only equation for this topic. Alright. Okay, we done with the normal stress, right? As I said before, we have 2. Before that, any question? Any ada soalan tak sebelum we proceed with shear stress? Okay. So kalau tak ada, we proceed with shear stress. So shear stress is same with the normal stress. The difference is only at A. Okay, at A area. So if the area for normal stress is perpendicular, so area for the shear stress is parallel. Alright. So this one. Okay, parallel. Right. For the shear stress. Let's say we have this, what we call this plate, okay, attached together in here. Alright. If the normal stress, the area is F over A. The area is this one for the normal stress. Alright. for the shear stress, okay, for shear stress we use the symbol tau. This is we call tau for the shear stress. Tau, V over A. For the normal stress, basically we use P over A, P. For the shear stress, we use V. The meaning is same, only symbol. In fact, the V for the shear load, P for the normal load, right? The unit is same, Newton, alright? So, for the tau is V over A. So, which A? So, A is the contact area. Let's say we have these two plates. Is contact between these two plates. The contact area is this one. This one the A. Okay, this one the area. So the area is parallel to the force. This is the direction of force, and this is the area for the shear stress. So we get the V over A. This one is V over A, right? Or if I draw in 2D, okay, let's say we have these two plates attached together like this, alright? And we have in here, and we have force in here, right? So the tau is V over A, or F over A. Area is area in contact area between these two, right? The area. And sigma is also F over A. This area, the perpendicular area, that is sigma, right? Okay, for shear stress, for shear in these topics, we have two types. One is single shear, the other one is double shear. What we call is double, let's say we have one plate in this way, and we attach one more plate at the bottom. This one, we only have one plate at the top. We put one more plate at the bottom. So, what is the value of tau? Okay, so long story short, if the single shear, you have formula. If the double shear, the formula is tau V over 2A, right? This is single shear. Single, this is double. Why double? Because you have two area, two contacting area, like this one. You have area at top and area at the bottom. So you have to put two area here, 2A, alright? So this is formula for single shear. This is formula for double shear, alright? The single and double shear is used when we want to study the shear stress at the pin, alright? Shear stress at the pin. Let's say this is not example, but this is more like explanation. So this is single shear, alright? This is single shear. If you look at this and compare with this one is double shear. How you want to separate this rod with this support? You only need to pull once. If you pull once, it's broken, right? So it's single shear. This is you pull once is broken this part, and then you need to pull once more, it's broken this part. So it's a double shear. You need to broken 2 times in order this rod release from this support. So it's a double shear. That's why you need to broken 1 times only, so it become release from the support. So this one is single shear, this one is double shear. Alright. So this is useful when we want to analyze the pin. Alright. So you have the pin here. Sorry. Okay. You have the pin here. Let's say I draw the pin in 3D. Alright. You have pin. Alright. And we have force like this. Alright. Force P. Alright. So the area is inside here. Here is the area, alright? If you want to find the tau, tau is V over A for single shear. Tau is V over 2A for double shear. So area is this cross section because P in this way. So P in cross section must parallel, alright? So A is this area, right? Right. Look at the equation. Look at the question. For each cases, determine the average shear stress the 20 mm diameter pin if the load is 5 kilonewton. Alright. If you have load 5 kilonewton P, okay, let's say this P is 5 kilonewton. This one is also 5 kilonewton. Alright. So for case 1, for the single shear, right, this one, so tau is V over A, which is 5 kilonewton over A, pi 10 squared, right? So you get the answer for the tau lah, for the pin, 5 over 16. You have 6 Pascal, right? This is for single shear. For double shear, you have tau is V over 2A, alright? So same P, 5 over pi 10 squared. So you get the answer. Don't forget 2. 2, right? So 5. So you should get 8 lah. 8 mega Pascal. Right? So this is your answer. Alright? So single and double shear. If they ask you for the normal shear for the road, just simply P over A lah. 5 over A for the road. Right? They say this road, they have this some cross section. So you need to find this value of A to find the normal stress for the road. Right, this is single, this is shear stress. Right, in this topic we will learn how to find the shear stress in pin. Right, for the pin. Okay, let's look at a more complicated example. So determine the average shear stress in 20 mm diameter pin at A and 30 mm diameter pin at B that support the beam. Alright. If we look at the pin at A, this is pin at A, you need to pull 2 times in order to separate this beam with this support. So this is double shear. Okay, this one you need only to pull once in order to broken this pin. So this is single shear. Alright. Sometimes the question will, sometimes the question will tell you pin A is double or single, pin B is double or single. Sometimes they did not tell you, so you need to identify using figure. Alright. Okay, so nak buat apa bermula? So you need to find the average shear stress in pin, right? So in order to find the diameter, the shear stress in pin, you need to find what is the force at A. What is AX? What is AY? And what is B? Alright. At B, this is 2 force member. Only have 2 points that has force. So this only have 1 F, B, C. Alright. Okay. This A, B, they have 3 force. Force at B, force at A, and force at here. So this is not 3 force member. So you cannot put only one direction of area at direction of force at A. You need to find both force at A. This one, because this one is 3 force member. Member at B they have force. Member at here you have force, and member at A you also have force. So this one is 2 force member because they have only 2 points that have force at B and at C only. Alright. So you need to find what is AX, what is AY, and what is BC, FBC using your knowledge in statics. Alright. So first, I think you need to draw the FBD. Alright. So I just draw here lah. So this one is AY, AX, and FBC. Alright. So summation of MA is equals to 0. Okay. So 30 kilonewton times 2 clockwise is negative, and then plus FBC times 4/5 times 6. Positive because it's counterclockwise. This is 6 is equals to 0. FBCX don't have the moment because it's one line. FBCY you have moment. Alright, so this is FBCY lah basically. Alright, so FBC you can solve directly is equals to times 5/4/6, 12.5 kilo Newton, right? FBC is 12.5 kilonewton. Okay, and then
Excuse me, sir.
yeah,
I'm sorry, sir, but can you repeat why AY doesn't have moment, sir?
FBCY have moment, FBS don't have moment. Okay, so here we have FB, CX, and also you have FBCY. All right. So FBCY we have moment. FBCX you don't have moment because it's in one line here. Right. So no
Okay.
moment.
Sir, one more thing, sir.
Yeah.
What about AY?
AY don't have moment because we want to find moment at A. So
Oh,
moment at
okay, okay.
A, the D is 0. All right.
Okay, okay. I forgot,
Okay.
sir. Thank you.
All right. Okay. So I proceed with this solution. All right. So you have proceed with next summation of fx is 0. All right. So you have ax plus fbc 3/5 is equals to 0. So you have ax. FBC we already find here. All right. 12.5 minus right. 3/5. So ax is 12.5 times 3/5 minus 7.5 kilonewton. Alright. Or 7.5 kilonewton in this direction. Right? Because we assume ax into the left, to the right, we get the minus, so it should be in the left direction. So summation of fy is 0. So you have ay minus 30 kilonewton plus FBC 4/5, which is 0. So AY minus 30 kilonewton plus FBC is 12.5, 4/5 equals to 0. So AY is equals to 30 minus 12.5 times 4/5. So 20 kilonewton. So positive. So our assumption is true lah. Kat atas. Right? Okay. So you have FBC, AX and AY. Right? So imagine that we have pin. Okay. Imagine that we have pin at B. I start with B first lah because it's easy. Because only one. So let's say at B, at pin B, we have pin like this. This is pin, alright? Pin, cylinder pin. Right, macam ni lah. Yang ni, this is pin, cylinder, alright? So, we have pin, and then we have, if I look at the front, I look from the front, it's like this, alright? So, you have FBC here. FBC, alright? Is equals to 12.5 kilonewton, right? Kadang dari depan, right? Potonglah buang line ni, right? FBC. So you find to the tau for BC is equals to V over A, right? V is same with force lah, alright, for the shear. So you have 12.5 kilonewton over area of BC. Area of BC, area of pin B. Area of pin B is 30 mm diameter, right? So here is the area is 30 mm. So pi 15 lah square, right? So you get the answer 12.5 over shift pi times 15 square. Over pi times 15 square, 17.68 megapascal. Alright, that is for pin B. Sekejap . Okay, this for pin B. So for pin A, you have two force. This is pin A. Pin A. Pin A, you have AX and you have AY. Okay, you have AX and AY. So you need to find the resultant first. Okay, to find B, you need to find the resultant of AX. Alright. Saya nak padam ya. Sekejap. Padam lah. So pin A, so pin A, you need to find resultant of pin A. A is equals to AX squared plus AY squared square root, which is 7.5 squared plus 20 squared and square root. So you get the A here. A resultant, right? So 7.5 squared plus 20 squared square root, 21.36 kilonewton. So this is your A resultant for the point A, right? For the point A. So find the shear stress for pin A. Shear stress for pin A is V over A. This is double shear. For A is double shear, so you need to put 2 at the front of A. Is equals to 21.36 Newton over 2A. So area for pin A is 20 mm, diameter for pin A. So pi 10 squared, right? So you should get the answer directly, 21.36 E3 over 2 times shift pi times 10 squared. So you have 34 mega Pascal. Alright, you have 34 megapascal. The TA. So this is your answer for TA. And then this is answer for your T tau B. Alright. Determine the average shear stress. Alright. So that's it for the shear stress at pin A and pin B. So the solid mechanics is sikit je. Yang banyaknya semua dekat sini lah. So this one is your statics. Right. This one is your statics. This one is your statics chapter 4. Right. So you need to mastering yourself chapter 4. Right. So this one is only little bit of a chapter 7. Okay. Any questions so far? Ada soalan tak? Okay. Let's look at reading quiz. What is the normal stress in the bar if P and the area is 500? So you have bar. Okay. P is 10 and area is 500. So it's simply 10 to the power of 3 over 500. Right? So 10 E3 over 500. So you get 20 lah. 20 what? 20 megapascal because it's Newton, this one is mm squared, right? So the answer is E, right? What is average shear stress in internal vertical surface A, B or C, D if F is 20 kilonewton? So this is double shear, you have two parts, depan dengan belakang. So tau is V over 2A, alright? So this one is 20, 10 to the power of 3 over 2A, 1000, alright? So your answer should be berapa? 20 kali 3 bagi 1000. 20 E3 bagi 2000 lah. Okay. So 10 megapascal. Ada tak? Tak ada. So inilah. So ini samalah. Megapascal. Alright. So I think that's all for the chapter 7 part 1. Alright. We have 3 parts. This is part 1. Alright. We have 3 parts. Part 1. Alright. So any question before we end here? So don't forget your test on next 2 weeks, alright, on 8 December is easy test lah. If you can do all the exercise, it's easy lah. Alright. Only chapter 4. Alright. So ada soalan tak? Kalau tak ada, we end here. Alright. So thank you everyone. if anyone of you is not clear about the video just now, I will upload the video at the Ulearn. So thank you. So don't forget to key in your attendance. All right, attendance. All right.
Thank you, Doctor.